Hello everyone. In this lesson, we're going to be talking about vectors. We're going to be talking about what is a vector and go over the graphical and the algebraic representation of a vector. Vectors show up in physics, and in physics in general, we have two types of quantities. We categorize quantities into two groups. One are the scalars, where you just have a magnitude, such as energy, for example, in joules, or distance between point A and point B in meters. That's a scalar. Some other quantities in physics are represented by vectors. Vectors have two things: magnitude, just like scalars do, but in addition to magnitude, they also have a direction. Examples of two vectors in physics: one is velocity. So you would say the velocity is these many meters per second or miles per hour in this direction, in the north south southeast direction, let's say, or northwest direction. And with the force, as you can see right here, if I have a mass lying on the ground and I'm pulling on that mass with force F, this arrow here represents a vector. The length of the arrow represents the magnitude of the vector, and the angle that the arrow makes with respect to the horizontal axis or the horizontal line is by definition the theta, the direction of that vector. So we will use magnitude being the length of the vector and the angle being the direction, the angle with the positive horizontal, positive x-axis essentially being the direction of the vector. So we will go ahead and represent a vector on a coordinate system. So here's the vector drawn in blue color. We're going to call it vector V. And as you can see here, I can drop the perpendicular from the end of V onto the x-axis and create this right triangle where the x component of that triangle, we're going to call that V sub x, and the y component, the vertical component of that triangle, we're going to be calling that V sub y. And as we talked about it, by definition, theta, the angle for this vector, the direction of this vector, is going to be defined by the angle theta, which is the angle between the positive x-axis and the vector. So these will be our definition. And this will be the graphical representation of the vector, whereby we're going to be calling V sub x and V sub y the components of vector V. And we can use the components in a vector equation. So we can either use it in writing the vector in its component form, or we can go ahead and use this to express the vector in a vector equation. So a component form or a vector equation are two different ways of representing the vector involving its components. Another thing we talked about earlier was that a vector has magnitude and direction. And if you're given the component form of a vector, the way you will go ahead and find the magnitude is using the Pythagorean theorem as it is applied to this right triangle that we have in the diagram. In this right triangle, the hypotenuse is going to be the length of the triangle. And as you can see here, for magnitude, we use this absolute value sign, or this um, double absolute value sign that represents the norm or the magnitude of the vector. And the direction can be found by using tangent theta equals to Vy over V sub x. So we can use that to find the angle if we're given the component form. Now, just something to add to the vector equation. What are these I hat and j hat? We're going to call them I hat and j hat. I hat and j hat are what we call the unit vectors. So we're going to be calling the I hat and j hat unit vectors. I hat is a unit vector in the x direction, positive x direction, and j hat is a unit vector in the positive y direction. And by definition, we call it a unit vector because the length or the norm of these unit vectors are 1. Anytime in math we have 1, we have the word unit, that means something is 1. In this case, the unit vector, the length of the vector is 1, which means when we get to multiply it by v sub x and v sub y, we can scale this vector. We can scale this vector. We can make it longer or shorter. So we're going to go ahead and look at an example here. So in this example, the question asks us, given a vector in the component form 3, 4, find the magnitude and direction of this vector. So first thing we did, we went ahead and showed the vector on the coordinate system. So we said along the x-axis, that's 3 units. Along the y-axis, that's 4 units. So for the length of the vector, for the magnitude of the vector, I'm going to use Pythagorean theorem. That's root squared of 3 squared plus 4 squared, which is equal to 5. And then I went ahead and wrote the vector equation for this vector, v equals to 3i hat plus 4j hat. And for the direction, we use tan theta equals to vy over vx, so that's 4 over 3. So I use a calculator and did the arctangent of 4 over 3, which is about 53.1 degrees. So I hope that you found this lesson useful and enjoyable. I will be following up this lesson with vector operations in the following videos. Thank you.